long time, but it's actually not a very long time. Look at the time flies. I have told you plenty of times previously as well. Like sometimes it's hard to believe that even the students who went for levels this time, it was like yesterday when they joined the class, like in grade 10. But time flies. I can't believe that 2 years passed. So same thing is going to happen to you as well. So don't take time for granted. No, the time is something that people always take for granted and it's so underappreciated. Right? මිනිස්සු හැම දෙයක් ගැනම හිතනවා කාලය කියන එක ගැන ලොකුට හිතන්නේ නැහැ. But time is actually so like it's one of the most valuable things we have because once time goes, we can't take it back. With that message, we'll start today's class. No, I suppose we have homework. We do. No, we do have homework. And can I ask, last week, have I sent the whiteboard note? Yeah. Last week was when? 17th, no? Whiteboard note ke wala naane. Lama, give me 1 second, please. Okay. So, what are I have sent the whiteboard note, the last, the week before the last, maybe last week, I will check and send you Lamai. Last week was 17th, Nene. 17th whiteboard note. Here I have it. So let me send it to the group. Some weeks I forget. Last week's whiteboard note. So we have finished the second lesson. I remember that we finished and we were doing some questions. What are the homework we have? What are the homework we have, Lamai?
Teacher, did we finish the lesson?
We finished the lesson, no? We didn't.
Yeah, we did.
We did. Okay. Then what are the homework we have?
Miscellaneous exercise, question 5 and 6.
Miscellaneous exercise, question 5 and 6. Okay, 1 second. Right. Okay. I think I sent you the wrong whiteboard note. No, where the whiteboard note? Okay, well, it should be this one. Hurry. Let me get the question to the whiteboard. Miscellaneous exercise 5th and 6th. Did we discuss the 3rd and 4th?
Yes, miss.
Okay. 3rd and 4th. We did. 5th question, let's take it. Okay. An object starting from rest and traveling along a straight line. Okay. So I think we did discuss a bit about how to draw a velocity time graph when they have given you the description, but we will do it once again. So, may I win? An object starting from, first of all, they're asking you to sketch the velocity time graph now. So, let me draw the shape of the graph first of all. Let's draw the shape of the graph, as in the axis. We have velocity and we have time. Velocity and we have time. Okay. So now we will read this. Starting from rest means, what is the initial velocity?
Zero.
Initial velocity is 0. If it's starting from rest means it did not have a velocity when it was starting, right? And now starting velocity is 0. That means it starts from here. Traveling along a straight line takes 8 seconds to acquire a velocity of 16 ms minus 1. 16 ms minus 1 velocity ka ganna, it took 8 seconds. So 16 here, 8 here, like this. Is that part clear to all of you? Api step by step yamu, because you may have this a bit confused, so we will do step by step. Is this part of the graph clear to all of you?
Yes.
Okay. Okay, then next it moves at a uniform velocity. Uniform velocity means constant velocity or the same velocity. It's moving at the same velocity for 4 seconds. Same velocity means now it's moving, it got 16 ms minus 1. So it's moving at that same velocity for 4 seconds. For 4 seconds. If it moved at this velocity for 4 seconds, what is the time that should come here?
12.
Yes. Here 8 seconds, then here 4 seconds. 8 in 4 gyanne, that is 12. Is that part clear to all of you? Okay. Ultimately decelerates for 4 seconds. Yeah, decelerate kana 4 seconds. Now it's here, it's 12 now. 12 in 4 kyan, it's 16. So decelerate karala, coming to rest. Comes to rest means what is the
Doesn't deceleration mean going backwards?
No. Deceleration means the velocity is decreasing. Velocity wala minus එකක් ආවොත් ඒ කියන්නේ opposite direction like this. So here, now don't get this confused. So here if you get velocity plus කියන්නේ එක direction එකකට යනවා. If the velocity is minus, it's moving in the opposite direction. Acceleration is different. Acceleration wala positive means the velocity is gradually increasing. That means it's speeding up. Minus means it's deceleration. That means the velocity is gradually decreasing. Like as if when brakes are applied, when the driver steps on the brakes. Is that clear?
Can you explain again, please?
Yes. Now, if you take if you take a displacement time graph, okay, displacement time graph. Displacement, the displacement is gradually increasing with time. Therefore, we say this is the velocity. If it's like this, that means the object is not moving. Displacement is constant. මේ පැත්තට කියන්නේ the velocity is like displacement එන්නේ අඩු වෙනවා නේ කියන්නේ opposite direction එකට යනවා. මෙතන velocity එක minus. Here the velocity is plus. Here the velocity is 0. Displacement is gradually increasing, so there is a velocity. Velocity is plus. Here displacement is the same displacement as the time goes. That means the object has not moved. Here the velocity is 0. If the object has not moved, that means there is no velocity in it. Then if the displacement is gradually becoming like decreasing as the time goes, we say velocity is negative. Velocity negative කියලා කියන්නේ ඇයි? Because the object is going in the opposite direction. This is a displacement time graph. But if you take a velocity time graph, okay, මෙන්න මෙහෙම, this part means as the time goes, velocity is gradually increasing. As if the driver steps on the accelerator in a vehicle, then the velocity or the speed is gradually increasing. Method acceleration like a positive. Acceleration is positive. Why? Because this vehicle is actually accelerating, no? Velocity is gradually increasing. Here, it's the same velocity. Here, acceleration is 0. That means there's no acceleration. The object is moving with the same velocity. Here, the velocity අඩු වෙනවා. Here, the acceleration is minus. When the acceleration is minus, we call it a deceleration. As if when the driver steps on the brakes, then the velocity or speed අඩු වෙලා අන්තිමට speed becomes 0. Is that clear, ළමයි?
Yes, thank you.
Okay, others? Others also, if you have any questions, ask. මගේ මේක කවුරුහරි WhatsApp එකේ අහලා තිබ්බ නේද? මම ඒකට answer කරා. I think it was Gitmi, no? No, not no, somebody. I can't remember. මගෙන් කවුරුහරි අහලා තිබ්බ ඒකට මම answer කරා ඔය plus minus එක. Okay? Anyhow. So now here, ultimately it decelerates for 4 seconds before coming to rest. During these 4 seconds, it decelerates. That means the velocity අඩු වෙනවා. And it comes to rest means it comes to this velocity 0 level. Here the velocity is 0. Velocity is 0, time is also 0. Is that clear, ළමයි? Okay. So that is the velocity time graph, Roman number 1. Roman number 2, my question එකේ චූටි case එකක් තියෙනවා. Find the deceleration during the first 8 seconds. It should be acceleration, no? It's a bit of a typo. The acceleration, can you change it, ළමයි? Okay. So now let's find the acceleration during the first 8 seconds. How do you find the acceleration from a velocity time graph? How do you find the acceleration from a velocity time graph? Yes.
Final
Hmm?
initial velocity.
Final velocity minus initial velocity divided by time. Ne, Kushit?
Yes.
Yeah, we can use that too. But when we have a graph, it is better to use the gradient method. Remember, I told you when you're finding acceleration from a any question, if there was no graph involved, you can use acceleration equals final velocity minus initial velocity divided by time. But if there is a graph involved, better to always go with the gradient. Because in a velocity time graph, the gradient always gives the acceleration. Now, if you look at this graph, to find the gradient, we have this point here, 0, 0. First 8 seconds, the points, I don't know any of these middle points. I know the first point, 0, 0. I know this point, which is 8, 16. This is the x value of the first point, so it's x1, then this is y1, this is x2, and this is y2. Now, how do I find the gradient? Gradient equals y2 minus y1 divided by x2 minus x1. Y2 is 16, y1 is 0. X2 is 8, x1, excuse me, x1 is 0. So 16 minus 0 is 16, 8 minus 0 is 8. So 16 divided by 8, we get 2 as the gradient. If the gradient is 2, what is the acceleration? 2 ms minus 2. If the unit is wrong, no marks, huh? 2 ms minus 2. Lamai Mauganda recorrections, I will give you time, but we will discuss like 2, 3 Roman numbers. It passamang okkoma recorrections ekata denna. Otherwise, every single step, if I give you time to do recorrections, it will take a lot of time, no? Okay. Let's, is this clear? Give me a thumbs up if it's clear. Okay. Then let's move on to Roman number 3. What is the distance traversed by the object during the first 8 seconds? First 8 seconds means this time, no? During the first 8 seconds. How do you find the distance or the displacement from a velocity time graph? We're talking about this part. First. What is it?
Area under the graph.
Okay, Jituli says area under the graph. Others also think the same. Maria also says the same. Yes. Distance or displacement we find using the area under the graph. Here the area under the graph takes the shape of a triangle, right? Okay, let's find it. Roman number 3. Triangle එකක area හොයන්න කොහමද? Half into base into perpendicular height. Half base is this, which is 8. The base here is 8. Perpendicular height is this, which is 16. So we will 2 times 1 is 2, 2 times 4 is 8, 4 times 16 is 64. Since area is 64, distance or displacement would be 64 meters. Is this clear to all of you, Lamai? Thumbs up. If you have questions, you can ask. Okay, great. Do the recorrections here. The graph. We did the first three Roman numbers. We drew the graph, second Roman number, and third Roman number. Quickly do recorrections. If you have like very lengthy recorrections, I will send the whiteboard note. But like small recorrections, you can do. I will give you 2 minutes. Okay, Lamai. Let's move on to Roman number 4. What does Roman number 4 say? What is the distance traversed at a uniform velocity of 16 ms minus 1? Uniform velocity part is this part. The uniform velocity part is this part. They are asking us the distance traversed during this. So again, distance is displacement. You find it using the area under the graph. Now here, this part is the shape of a rectangle. And we know how to find the area of a rectangle. That is length into breadth. So here the length is 16. Breadth is, what is the breadth here? What is the breadth here? Metana gap 8 to 12. The gap is 4. 4. Yeah, 4, right? The gap is 4. So length is 16. Gap is 4. That should be 16 times 4, 64. Since area is 64, displacement here is, you just put the unit. 64 meters. Is that clear to all of you, Lamai? Is it? Others? Okay. Find the deceleration during the last 4 seconds. Last 4 seconds is this part. Now, deceleration is the same as acceleration, but it's negative. Acceleration valama negative එක තමයි deceleration කියලා කියන්නේ. So before getting deceleration, we have to calculate the acceleration. In this part, we know this point. Here, x value is 12, y value is 16. So that is x1, y1. And I don't know any middle points, but I know the ending point. In the ending point, the x value is 16. The y value is 0. So that is x2, y2. So Roman number 5. And we know how to find acceleration, right? Using the gradient. Sorry, gradient. Gradient equals y2 minus y1 divided by x2 minus x1. y2 is 0, y1 is 16. So 0 minus 16, x2 is 16, x1 is 12. 16 minus 12. 0 minus 16 is minus 16. 16 minus 12 is 4. So minus 16 divided by 4, you get minus 4. If the gradient is minus 4, acceleration is minus 4 ms minus 2. Then what is the deceleration, Lamai? They're asking us the deceleration. What is the deceleration?
ms minus 2.
4 ms minus 2. Whenever you have a negative acceleration, एक minus का drop करला, you write the value for deceleration. So you remove the minus, you just write 4 ms minus 2. That is the deceleration. Is it clear to you? Clear to all of you, Lama? Give me a thumbs up. Okay. All right. Last question, find the distance moved during the last 4 seconds. So distance is displacement. We find it using the area under the graph. Here the area under the graph is a triangle. So Roman number 6. Let's find it. Area equals half into, here the base is 4, no? 12 to 16 means there's a gap of 4. Perpendicular height is 16. 2 times 1 is 2, 2 times 2 is 4, 2 times 16 is 32. If the area is 32, displacement is 32 meters. Okay, Lamai. So I will give you, for all the recorrections, I will give you 5 minutes. Quickly do any recorrections you have and we will move on to the 6th question. Make it fast, really fast. Lama, have you all finished corrections? Shall we move on to the sixth question? Sixth one is gravitational acceleration, which is where we stopped last week. Okay. Anyways, we can't take too long. Let's just quickly move on. A fruit in a tree that detaches from the stalk takes 4 seconds to fall to the ground. To visualize it, let me just draw a sketch. So there's a fruit that detaches from the stalk and it falls down. It takes 4 seconds to reach the ground. To like fall onto the ground, it takes 4 seconds. Okay. What is its velocity when it reaches the ground? Method the velocity kahana. What is the initial velocity of this fruit? What is the initial velocity of this fruit?
0 ms minus 1.
0 ms minus 1. Because it's dropped, right? It's just falling down. Nobody's like throwing it downwards. So initially the velocity is 0. So initially the velocity is 0. It takes 4 seconds. Final velocity, we don't know. That is what they're asking. So what is the equation that we use? Acceleration equals final velocity minus initial velocity divided by time. Do we know the acceleration here? Do we know the acceleration here? When a fruit is falling down from a tree and reaches the ground, do we know the acceleration? I'm getting different sound.
No.
What is it, Kushit? We do know
No. Accelerate.
is gravitational acceleration, no? Because when it's falling down, it's gravitational acceleration. When it is gravitational acceleration, we know it's 9.8, but we use it as 10 because it's easy for calculations. So here acceleration we know. Acceleration is 10 ms minus 2. Final velocity we don't know. That is what they're asking you to find. Initial velocity I know because it was dropped from the stalk. So it starts with 0. Time also I know it's 4 seconds. So here we have 10. V minus 0 is V divided by 4. What I'm going to do is I'm going to take this 4 to this side. Then it becomes 4 multiplied by 10. On this side we have V. So V is equal to 4 multiplied by 10 is 40. Since V is velocity, I put the unit as ms minus 1. So velocity is 40 ms minus 1. When it reaches the ground, its velocity is 40 ms minus 1. Is that clear to all of you, Lamai? Give me a thumbs up if it's clear. If you have any questions also, you can ask. Clear? Okay. There's a Roman number, there's a B part, ne? This is A. Find what is the height that it fell from. So now they're asking us this height. How do you find the height here? Kianma, last week we learned this. How do you find the height here? Get me 9.8 dala answer gattot instead of 10. That is not wrong. However, in the exam or in any question, usually gravitational acceleration, we take it as 10. At the front of the paper, they say take G as 10 ms minus 2. But if you use 9.8, there's nothing wrong with that. But always in the exams and in the future for gravitational acceleration, So calculations, better to use 10. Okay. Okay. Yes. Height amai metana, height is the same as displacement. And how do you get the displacement? Using mean velocity. So first we calculate mean velocity. Mean velocity is initial velocity plus final velocity divided by 2. So initial velocity, now we know it's 0. Final velocity, now we know it's 40, right? So initial velocity is 0 ms minus 1. Final velocity is 40 ms minus 1 divided by 2. 0 plus 40 is 40. 40 divided by 2 is 20. So mean velocity is 20 ms minus 1. Then displacement is mean velocity multiplied by time. So mean velocity now I calculated here as 20. Time they have given as 4 seconds. 1 second. Time is 4 seconds. So 20 multiplied by 4 is 80 meters. If the displacement is 80, displacement is the same as height. Therefore, height is also 80 meters. Is this clear to you, Lamai? Give me a thumbs up. Okay, may part ke corrections karaganna. I will give you like 3 minutes. And then we'll move on to the second Roman number. Quickly do the recorrections, Lamai. Okay. Now, Roman number 2. So I will separate it here. And let's do Roman number 2 on this side. Lamai, I may have told you about a seminar that we have. Not necessarily for you guys. It's just open for public. Anybody can join. එතර ඔගලන්ගේ යාළුවෝ කවුරු ඉන්නවා නම් interested, you can ask them to join. You don't really have to join මොකද අපි ඔක්කොම class එක කරනවා ඒ lesson එක. We are doing the third lesson. That means the lesson that we will be starting today is what will be covered in the seminar. So එකින්ද ඔගලන් seminar එකට I mean if you want to join you can join, no problem. But you don't like, it's not a must. But if you have any friends that who are not coming to the class, it's free. Anybody can join. Okay. So you can let them know. I will send you like the post that we shared. Then you can circulate it among your friends as well. Okay. Roman number 2. An object is projected vertically upwards at an initial velocity of 30 ms minus 1. An object is projected vertically upwards with an initial velocity of 30 ms minus 1. එයාව පල්ලෙහා ඉඳන් උඩට throw කරනවා. Initial velocity is 30 ms minus 1. Find the time taken by the object to reach its maximum height. මෙයා උඩට ගිහිල්ලා the place where it stops. What is the velocity? This object goes up, 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 and at some point it will stop. No, stop going further up. At that point, what is the velocity of this object? What is the velocity of this object? At the very top position, the velocity of this object is 0 ms minus 1. Okay? We discussed this last week. Huh? At the very top position, the velocity is 0 ms minus 1. අහන්නේ අපෙන් time එක. Time එක තමයි අපෙන් අහන්නේ. When an object is moving upwards, lamai, what is the velocity? Sorry, acceleration. I'm sorry, I told the wrong word. Not velocity. When an object is going up, what is acceleration? In gravitational acceleration, when the object is moving down, the acceleration is 10 ms minus 2. When the object is moving upwards, it's minus 10 ms minus 2. Huh? මෙතන එතකොට එන්නේ minus 10 ms minus 2 if it's going up. Don't forget that. So they're asking us the time. මේකට මම use කරනවා මේ formula එක. Let's see how to do this. Huh? We are using the same formula as acceleration equals final velocity minus initial velocity divided by time. Here the final velocity is 0 ms because at the top position, the final velocity is 0. 0 ms minus 1. Initial velocity is 30 ms minus 1. Time done in it. Acceleration, I know it's minus 10. Okay. Now what I'm going to do is, I'm going to bring this t here and minus 10 here. So t metantahama, that is t equals, here 0 minus 30 will be minus 30. May minus 10 ma pallehata gena, then it's minus 10 ms minus 2. So time will be 30 divided by 10 is 3. Minus divided by minus is plus. Since it's time, the unit is seconds. So we get the time as 3 seconds. Is that clear to all of you, Lamai? Others? Okay. Now, let's move on to the next one. Maximum height. Now we know how to find the height. Height එක හොයන්න වෙන්නේ අපි කලින් කරා වගේම තමයි. Here, this is the height. How do you find height? As displacement. And displacement, how do you find? Using mean velocity. Mean, මම මේ formula එක මෙතනින් ගන්නම්. So I have a question. Can you just say time equals to initial velocity divided by gravitational acceleration? එහෙම කියන්න පුළුවන් because 30 is initial velocity divided by gravitational acceleration, but it's not just initial velocity. Final velocity minus initial velocity කියන එක ගන්න ඕනේ. If it was just the initial velocity, නිකන් 30 ගෙන් minus 10 divide කරන්න තියෙන්නේ. But here it's minus 30, not just 30. Okay? So always now, when you consider different questions, the way, so sometimes you will feel like මේක නිකම්ම මෙහෙම කරා නම් හරිනේ කියලා. හැබැයි එක එක questions වල එක එක විදියයිනේ. ඒතකොට හැම question එකකටම හරියන විදියට we can't memorize a lot of different equations. So better to memorize one equation and apply it to all those questions. So that would be the smart way. So something that I always tell you all is that I will be telling you, and I might have already told you, is that it's more important to study smart than study hard. Why is that? Because studying hard doesn't make you like, ඔයගොල්ලන් හිතන්නේ උදේ ඉඳන් රෑ වෙනකම් මහන්සි වෙලා පාඩම් කරලා even රැට නිදා ගන්නෙත් නැහැ, පාන්දර හැරෙනවා. එච්චර පාඩම් කරන්න ඕනේ නැහැ O levels වලට. Right? But you have to study smart. Okay, එක equation එකක් memorize කරගෙන ඔක්කොටම දානවා. ඊට පස්සේ මම ඉස්සරහට ඔයගන්ට කියනනම් I will share with you certain tricks and certain strategies that you can use to keep things in memory for a long time. I will also tell you how to study. ඒව දැම්ම මම ලොකුවට කියන්න යන්නේ නැහැ because it's still too soon. But I will tell you in due time how to study and all that. ඒකයි දැන් O level දැන් ඔයගොල්ලෝ අම්මලාට කියද්දී අම්මලා සමහරට ඔයගොල්ලන්ට බයින්න පුළුවන් when I say you don't have to study very hard for O levels. But it's true. I always tell you, y'all are like 15 years old. 14, 15 වගේ ඔයගොල්ලන්ගේ දැන් age එක තියෙන්නේ. So 14, 15 means you are still children, right? So you don't have to spend 24 hours study. You have to go to school. You have to spend time with your family, with your friends. Maybe like, I don't know if you all play games or anything like that, sports, then watch things on TV, ඒ වගේ දේවල් කරන්න ඕනේ, right? Because that's just being children. Because when you come to a certain age, when you become an adult, you will realize you won't have time to do any of those. So ඔය කාලේ තමයි හැමදේම කරන්න තියෙන්නේ. ඒකින්ද 24 hours if you study, you won't have time to do anything else. That is not what I want from you. What I want from you is to study smart and like, you know, with right strategy. ඒකට දැන් මම උගලන්ට එක දෙයක් උගන්වන්න මම කලින් කියලා තියෙනවා. When you now let's say today you are learning something, right? So when you learn this today, tomorrow take 5 minutes and go through this. Then day after tomorrow ඕනේ. ඊට පස්සේ දවසේ I take 5 minutes and go through what you learned. එහෙම සතියෙම කරන්න. කරාම ආමත් මේක අමුතුවෙන් you don't have to spend time to study. It will be in your memory for some time. Okay? So usually when you learn something, immediately if you go over it a few times, ඒක ඔයගලන්ගේ long term memory එකේ රැඳෙන්න තියෙන chance එක වැඩි. දැන් ඔයගලන් අද මේක learn කරනවානේ. You learn this today and you go through this note after like 1 month. Then there might be a lot of things that you might have forgotten by that time. ඒක හොඳ වැඩක් නෙවෙයි. එතකොට you have to spend more time to study it all over again. එහෙම ඕනේ නැහැනේ. Then you are learning this. Now it's fresh in your memory. So හෙට උදේ හරි දවල් හරි කොයි වෙලේ හරි you take like 5 to 10 minutes, just quickly go through the pages. Then what you learn gets sealed. Always seal වෙනවා එක. Right? ඊට පස්සේ ආයේ the හෙට කියන්නේ Wednesday you go through it 5 to 10 times. I'm not asking you to study like for 2 hours. Just 5 to 10 minutes. Just go through the pages. Memonada, this is this, this is that. Just go through what you learned today. Then I'm a Thursday balandone. Again, Friday, go over it one more time. 5 to 10 minutes. Okay. So if you divide your time nicely, you will not be overwhelmed by the amount of things you have to study. එහෙම නැති වුණාම තමයි exam එක ලඟ වුණාම කඩියා කාලා වගේ you are like very stressed out panicking and like මාර කලබල වෙලා එහෙම පාඩම් කරන්නේ අන්තිම වෙලේ අර මුලදී මොනවාම බලන්න නැතුව ඉතින් මුලින් ඉඳන්ම චුට්ට චුට්ට බැලුවාම you don't feel overwhelmed. Okay, it's also very important to take care of our mental health නේ. නේද? අන්තිම වෙලේ stress වෙලා බොරුවට එහෙම එච්චර වෙන්න ඕනේ නැහැ. ඒකත් මම ඔයගන්ට daily පාඩම් කරන්න කියන එකේ I'm not asking you to study for like 2-3 hours. Just 5, 10, maximum 15 minutes. Just go through what you learned. Okay? The first lesson එක එහෙම කරේ නැත්නම් you will have to spend some time to study that again, revise that again because you may have forgotten a lot. But second lesson I think you can still do that. Just පොඩ revise කරන්න ඔයගන්ට තාම පුළුවන් because it's still fresh in your memory. Okay? Don't let things to get accumulated. ඔක්කොම ගොඩ ගැහෙනකන් ඉන්න එපා කරන්න. Okay? Right. Mean velocity. Initial velocity is 30 ms minus 1. Final velocity is where it stops. That's 0 ms minus 1. Divided by 2. 30 plus 0 is 30. 30 divided by 2 is 15. So mean velocity is 15 ms minus 1. Then displacement කියලා කියන්නේ mean velocity multiplied by time. Mean velocity is 15 ms minus 1. Time is 3 seconds. 15 times 3 is 45. So it's 45 meters. If the displacement is 45, height is also 45 meters. Is this clear to you, Lamai? Give me a thumbs up. Okay. May A, may B. And finally, let's also discuss the C part. Sketch the velocity time graph for the motion until it reaches the maximum height. I won't like use all straight lines. එහෙම කරන්න නැහැ. ඔයගොල්ලන් හැබැයි rule එක තියලා draw කරන්න. I will just draw a very rough sketch. You have to label the axis. Y axis එක velocity කියලා label කරලා තියෙන්න ඕනේ. Brackets ඇතුළේ unit එක දාලා තියෙන්නම ඕනේ. Right? නැත්නම් ලකුණු කැපෙනවා. X axis is time. Within brackets put seconds. If you look at this motion, initially it has a velocity. Initially its velocity is 30. Initially it starts with velocity 30. ඉවර වෙනකොට velocity එක 0. And how long has it taken? 3 seconds. එහෙනම් here time is 0. Time 3 වෙනකොටම velocity 0 වෙනවා. So the graph should be like this. Did you get the graph like this, Lamai? Initially velocity is 30, but during the 3 seconds, velocity comes like decreases and comes to 0. Is that clear? Okay. Again, I will set a timer for 5 minutes to do any recorrections. Your time starts now. Quickly do the recorrections and we'll move on to a brand new lesson. Quickly. Lama, did you all do the recorrections? Everybody? Done? Anik time bukade. What about others? Okay. Then we will move on to our new lesson, put the topic structure of matter. I was initially planning on sending you the PDF, and then I realized there's a lot of like activities to do. I mean, questions to do and all. So it's better to handwrite the note. Mula ටිකේ තමයි චුට්ටක් ලියන්න තියෙන්නේ, and then the rest of it we just have to do questions and all that. So let's handwrite this note. Structure of matter. Okay. Now, Lamai, before we talk about anything else, we'll talk about what matter is. Right? What is matter? Matter කියලා කියන්නේ, when it comes to matter, matter can either be solid, liquid, or gas. Anything that we consider as matter is either solid, liquid, or gas. Okay. So, for one thing, matter can be divided as solid, liquid, and gas. Then, that is one way of dividing matter. Another way how you can divide matter is as pure substances and mixtures. Pure substances and mixtures කියලා කියන්නේ ළමයි, you have you all learned this in grade 9? No? Anyways, we will discuss it little by little. We are not going to talk too much about these yet. You have, ne? We're not going to talk too much about this because these are things that we will be discussing gradually, right? So in this lesson, we are going to be talking about elements. And then in grade 10, there's a lesson called chemical compounds where we'll be learning about compounds. And then there's another one called mixtures in grade 11. එතන මේ ඔක්කොම අපි O-level වල එක එක stages වලදී ඉගෙන ගන්න. For now, we will just get a rough idea about everything. And more details we will learn as we go during grade 10 and 11. Matter can be divided into two as pure substances and mixtures. Okay. Then pure substances can be divided into two as elements and compounds. Mixtures can also be divided into two as homogeneous mixtures and heterogeneous mixtures. And mixtures. So, Lamai, now when it comes to matter, one way of dividing them are, as I said, solid, liquid, gas. Some of the matter are solid, like this table is made of wood. My phone is made of like metal and wire or something like that. The bottle is made of plastic. Then curtains are made of cloth. So they're all solids. The liquids got the hammer. Inside the bottle, I have water. There's water. Inside my body, there's blood, right? So there are so many liquids. There's coconut oil, there's kerosene, there's water, there are like different soft drinks, all that. Then gases, in this atmosphere, there is oxygen gas, nitrogen gas, carbon dioxide, so many different gases, right? Then another way of dividing matter is as pure substances and mixtures. Pure substances වල ಜಾති දෙකක් තියෙනවා, elements and compounds. Elements means these substances are made with just one element. Oxygen and just oxygen. Hydrogen and just hydrogen. Sodium and just sodium. Magnesium and just magnesium. Just one atom, one element. Compounds කියන්නේ some things are made of several elements together. If you take water, water we write as H2O. That means water හැදිලා තියෙන hydrogen atoms දෙකකුයි oxygen atom එකකුයි. Hydrogen දෙකයි oxygen එකයි. Then carbon dioxide is something like this. Carbon dioxide gas is made of one carbon and two oxygens. Then there are things called ammonia, compounds. Those are compounds. Then if you take mixtures, mixtures are substances where two things have come together. Homogeneous mixtures can mix වෙලා තියෙනවා. For an example, if you mix salt and water, they mix very well. If you take salt and water, they mix very well. If you take sugar and water, they also mix very well. Those are called homogeneous mixtures. Heterogeneous means they don't mix very well. For an example, if you take wheat flour is lamai palm piti. Or we also call it thiringu piti. Wheat flour and water, they don't mix very well. Then if you take coconut oil and water, do they mix? Have you seen how coconut oil and water is when you put them together? What do you observe?
It floats on water.
Coconut oil floats on water, yes. That is because they don't mix well. We call those heterogeneous mixtures. May lesson එකේ ඔයා මේ compounds, homogeneous mixtures, heterogeneous, you don't need to know about this. Elements ගැන ටිකක් දැනගත්තාම ඇති because we will anyways be talking about those. But compounds, it's a different lesson. Homogeneous, heterogeneous mixtures, different lesson. So don't worry about them too much. Compounds වල චුට්ටක් අපි මේ lesson එකේ කතා කරනවා, but we are mostly going to be talking about elements. Is this part clear to you? Okay. Put a subtopic. Put a subtopic, classification of matter. And can you all draw this? Classification of matter කියලා subtopic එක දාගෙන මේක ඉක්මනට draw කරන්න. Quickly. Lama, can you all hear me? Can you all hear me, Lama? Okay, I'm sorry, I had a connection issue. So you may have lost the board. Have you all finished writing? Let me give me a second now. I'll share the board. But did you all still writing? Or done? Hmm? Anybody who needs more time? You need more time, Maria? Ah, okay, okay. I will give you more time. Give me a second. I think there's a bit of a network problem. My whiteboard is not loading. Please give me. Ah, okay. Now it's. Wait a second. Okay, I have shared the whiteboard. For those of you who cannot see, I will send the link. Can all of you see the whiteboard? Hari. Okay, I will give you a few more minutes. Quickly write this. Make it fast. Quickly write. Huh? For those of you who are still writing, I will give you 2 minutes. Huh? I'll set a timer. Once the 2 minutes are over, we are moving on. Huh? Forty-five seconds left. Okay. Now, Lamai, now that we have learned the classification of matter, we are going to be talking about this lesson, like properly starting this lesson now. So, in grade 9 also, you have learned this, all substances, everything in this earth or in the space or wherever, everything is, all matter is made up of atoms. Whether it's a solid, whether it's a liquid, or whether it's a gas, if it is a matter, it's made up of atoms. Okay. So there was a guy called John Dalton. John Dalton කියලා කෙනෙක් හිටියා. එයා තමයි atoms ගැන හොයාගන්නේ. John Dalton කියනවා all the substances in the world, if you break it, and further break it down, the smallest particle that you can get is the atom. Unfortunately, atom එක ඔයාට මෙහෙම බැලුවට පේන්නේ නැහැ. Atom එක microscope එකකට දැම්මත් පේන්නේ නැහැ. It's that small. So if you take this bottle for an example, it's made of plastic, right? So may plastic හැදලා තියෙන්නේ like millions and billions and trillions of plastic atoms. Atom එක තමයි හැදිලා තියෙන්නේ. If you take myself, I'm also like that. My body and my, like, all the organs, everything is made of atoms. Same with you. All the matter in this, on the earth or in this world or whatever we think of, whether it's a solid or a liquid or a gas, everything is made of atoms. So John Dalton කියනවා ඒක තමයි පොඩි මේක කියලා. And then later on, other scientists came. එක්කෙනෙක් ඇවිල්ලා කිව්වා, yes, atom is the smallest unit. හැබැයි atom එකටත් වඩා පොඩි කට්ටිය ඉන්නවා. එයා කියනවා atom එක ඇතුළේ ඉන්නවා protons කියලා જાතිය. Then another scientist came. එයා කියනවා atom එක නෙවෙයි smallest එක. Inside atoms, protons වලට අමතරව there's another particle called electrons. Then another guy comes and says, yes, protons and electrons are there. In addition to this, there's another particle called neutrons. Now, all of these are found inside the atom. So at one point, everybody believed that atom is the smallest unit and everything is made of atoms. But later, 3 scientists came and said, no, atom is not the smallest unit. Inside the atom also, there are other small units called protons, electrons, and neutrons. Okay. එතකොට සාමාන්‍ය කියනවා, if you take an atom, right? If you take an atom, like let's say, let me draw something like this. Let's say this is an atom. මේ atom එක මැද චූටි space එකක් තියෙනවා. චූටි area එකක් තියෙනවා. It's very small. Inside the atom, we call this a nucleus. This entire thing is atom. Huh? This entire thing is the atom. Inside the atom, at the very center, there's a very tiny little area, a region, we call it the nucleus. Now, inside the atom, we have protons, electrons, and neutrons. No, මෙතන protons and neutrons are inside the nucleus. Protons and neutrons are inside the nucleus. Then where are electrons? Electrons lamai me vate space එකේ තමයි electrons in. Electrons are found in this space. Okay. So electrons are found in this space. In the atom, at the very center, we have a nucleus made of protons and neutrons. And then outside space, we have electrons. That is how the atom is made of. Up to that point, is it clear? So, main electrons so let's say this is an electron. Electrons are just rotating or revolving around the nucleus. Let's talk about that later. But for now, I hope you understood this. So, just for you to get an idea about the size of the atom and size of nucleus. Api hitanna, let's say there is like a football ground. You can imagine the size of a football ground. Ne? So, some of you might even be watching football, right? Football balana kattiyat ඇති. Football බලුවේ නැතත් ඔගාන football ground එකක් ගැන idea එකක් තියෙනවනේ කොච්චර size එකක්ද කියලා. If you keep a chickpea, what is chickpea? Chickpea is kadala, right? So if you take one chickpea and you keep it at the middle of the football ground, if the football ground is atom, that chickpea would be the size of a nucleus. ඒ කියන්නේ මෙහෙම ෆුට්බෝල් ග්‍රවුන්ඩ් එකක් තියෙනවා නම් ওই ෆුට්බෝල් ග්‍රවුන්ඩ් එක මැද ඔයා මෙන් චූටියට කඩලැටයක් තියෙනවා. මේ ෆුට්බෝල් ග්‍රවුන්ඩ් එක ඇටම් එකක size එක නම් that කඩලැටේ is the size of the nucleus. So again, you can understand how small the nucleus is compared to the atom. Atom එක මැද ගොඩාක් tiny little region එකක් තමයි nucleus කියලා කියන්නේ. Is it clear? Shall we write then? All good, no? If you have questions, you can ask. Hari, put a subtopic atoms. Atom. Put a subtopic atom. Atom. You can write with me. Write with me, then we can save time. So my protons are positively charged, huh? Electrons are negatively charged. And neutrons don't have a charge. They are neutral. The charge is zero. It's not positive, it's not negative. එතකොට චුට්ටක් ඔයගොල්ලෝ like stop writing for a second and listen to me. Now protons are positive, electrons are negative, and neutrons have no charge, zero. So if you take the nucleus, protons are positive, no? Protons are positive, neutrons don't have a charge. Then what would be the charge of the nucleus? What would
Positive.
positive? Positive, no? Because protons are positively charged. Neutrons don't have a charge. In a nucleus overall gathama will have a positive charge. And electrons are just negative. Okay, quickly write this lamai. And again, may atin podi sketch එක draw කරගන්න. Make it really faster. Shall I set a timer? 6 minutes. Make it fast. 1.5 more minutes lamai. Make it fast. Dan lamai, give me a thumbs up if you have finished. All right. Now, don't write anything, just listen. Now, there was a guy called Ernest Rutherford. මේ Ernest Rutherford තමයි මේ nuclear model කියන එක කියන්නේ. එයා කියනවා ඒකේ nucleus එක මැද තියෙනවා, පටේට electrons ටික revolve වෙනවා. Nucleus එක ඇතුලේ තමයි protons and neutrons තියෙන්නේ. Ernest Rutherford තව model එකක් කියනවා. That model is called the planetary. Don't write, don't write. I will give the note later. That is called the planetary model of the atom. Now, have you seen you must have seen pictures of the solar system, right? If you take the solar system, what is at the very center? What is at the center of the solar system?
Sun.
Yeah. What are revolving around the sun?
Planets.
Asteroids and planets.
Planets, asteroids, and there are other particles as well, like comets and all that, and mainly planets. So we know that there are 8 planets revolving around the sun. Quite a few years back, there was also, we considered that there are 9 planets, including Pluto at the very end. But then later, Pluto seemed to have drifted away. So it's slowly drifting away and away. So we don't consider Pluto to be a planet anymore. So planets we consider, there are 8 planets. So sun ge ළඟ ඉඳන් බැලුවාම which planet is Earth? First or second or third or fourth or fifth or which planet? From the sun ge ළඟ ඉඳන්.
Mercury.
Mercury is the first one. Then which one is Earth?
Third.
Third, not fourth, third. Mercury, Venus, yes. Third one, yes. Mercury is the first one. Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Right? එතකොට ඒ වගේම තමයිලු atom එකෙත් වෙන්නේ. Just like in the solar system, sun is at the middle now. Just like that, in the atom, nucleus is at the middle. Is the nucleus. Planetary model එකේ sun එක මැද ඉන්නවා වගේ, in the solar system, sun එක මැද ඉන්නවා වගේ, In the atom, nucleus is at the center. And in the solar system, planets are revolving around the sun. Just like that, in the atom, electrons are revolving around the nucleus. අපි මුලින් කිව්ව electrons දෙකක් ඉන්නවා විතරයි කියලානේ. මේ nuclear model එකේ. දැන් මෙතන අපි කියනවා electrons are revolving around the sun like this. Sun නෙවෙයි මෙතන it's a nucleus, right? Electrons are revolving around the nucleus like this. Like this. Okay, so this is just a few. There are more. So nucleus is at the middle and electrons are revolving around the nucleus. Just like in the solar system, planets are revolving around the sun. Etakota, now I have a question. Okay. We know, okay, so nucleus is here and electrons are revolving around the nucleus. Why aren't, now you know nucleus is positively charged. Here we learnt it already. So me mada in a nucleus එක nucleus is positively charged. Why is it positively charged? Because there are protons. Neutrons anyways don't have a charge. The charge is 0. But protons have a positive charge. Therefore, nucleus is positive. Then if you take electrons, electrons are negatively charged. So my question is, now we know that positive and negative are always attracted. Positive, negative, always attracted. Why aren't nucleus? So electrons are negative, nucleus is positive. And positive, negative, හැමලේම attract වෙනවා. So then, why are these electrons, why aren't they just getting attracted to the nucleus and just falling onto the nucleus? Electrons negative, nucleus එක positive. ඒතර electrons මෙම attract වෙනවනේ nucleus එකට. Attract වෙලා මෙම nucleus එකට වැටෙන්නේ නැහැ. ඇයි එහෙම වැටෙන්නේ නැත්තේ? Or like, do you have different opinions on that? Why do you think? I hope you understood the question. Nucleus is positively charged. Electrons are negatively charged. Nucleus, so positive and negative always get attracted. Then why aren't electrons attracted to the nucleus and just falling onto the nucleus? Why is that not happening as you think? That is because now electrons are revolving around the nucleus. When electrons are revolving around the nucleus, they are not just moving slowly. They are moving very fast. Since they are moving very fast, they don't have time to fall onto the nucleus. Nucleus එකට වැටෙන time එකක් නැහැ. මොකද ඒගොල්ලන් ගොඩාක් fast nucleus එක වටේ revolve වෙනවා electrons. Electrons ගොඩාක් fast යන nucleus එක වටේ. ඒකින්ද ඒගොල්ලන්ට වැටෙන්න වෙලාවක් නැහැ because they are moving too fast. That's why electrons are not falling onto the nucleus even though they are positive and negative. Also, then now, this was put forward or this was introduced by Ernest Rutherford. Ernest Rutherford de කිව්වේ ඔය planets solar system එකේ revolve වෙනා වගේ තමයි electrons nucleus එක වටේ revolve වෙන්නේ. Then came another guy called Niels Bohr. Niels Bohr කියලා කෙනෙක් ආවා. Niels Bohr කියනවා, when electrons are revolving around the nucleus, they don't randomly revolve, they have fixed paths. ඒ කියන්නේ මේ electron එක ගත්තොත් එයා move වෙන්නේ මෙන්න මේ path එකේ. එයා මෙහෙම randomly යාට ඕන විදිහට මෙහෙම move වෙන්නේ නැහැ. It's moving on its path. If you take this electron, එයා මෙහෙම randomly එක එක තැන්වල move වෙන්නේ නැහැ. It has its own path, so it's moving on that path. Then if you take this electron, it's moving on its path. Then if you take this electron, it's moving on its own path. Likewise, all electrons have definite paths. Right? All electrons have definite paths. These parts, we called them shells. We call them shells. මේ parts වලට අපි කියනවා, we either call them energy levels or we also call them shells. Then Niels Bohr has even labeled these shells. මේ shells නැත්නම් මේ energy levels label කරලා තියෙන Niels Bohr. කොහමද? First, which part Sala? The energy levels part.
Yes.
Okay. So energy levels part එක තමයි now nucleus is at the center. Electrons are revolving around the nucleus no. So if you take this electron, මේ electron එකට මෙහෙම එක එක විදියට ඕම එක වටේට මෙහෙම යන්න බෑ. Electrons cannot randomly move around the nucleus. They have specific paths. If you take this electron, එයා revolve වෙන්න ඕනේ යාගේ path එකේ. මේ තමයි යාගේ path එක. If you take this electron, එයා revolve වෙන්න ඕනේ යාගේ path එකේ. This is its path. So it has to stick to its path. If you take this electron, it has its own path, so it has to stick to that path. Likewise, all electrons don't just randomly move around the nucleus. They have definite paths. Or they have like certain paths. ඒගොල්ලන්ට මේ path එකේ තමයි යන්න ඕනේ. Randomly මේ යන්න බෑ. Okay? So මේ paths, electrons move in a paths වලට අපි කියනවා energy levels or shells. Is it clear, Sala? Others, is that clear up to that point? මේ කියන්නේ Niels Bohr. This energy levels part is introduced by Niels Bohr. Others? Ko thumbs up කොඩ්ඩයිනේ. What about others? Okay. Not only that, Niels Bohr has even labeled these energy levels. එයා මේ parts වලට energy levels or shells කියලා නම් කරනවානේ. Not just naming, he has even labeled each energy level. එයා කියනවා first energy level එකට we can say 1. Second energy level we can say 2. Third energy level we can say 3. Fourth energy level we can say 4. Numbers වලින් යනවා නම් එහෙමයි යන්නේ. If you are using letters, you can write like this. First energy level, we call it K. Second energy level, we call it L. Third energy level, we call it M. Fourth energy level, we call it N, and so on. So numbers වලින් යනවා 1, 2, 3, 4. Letters වලින් යනවා K, L, M, N. Is that clear? Okay. There's more. තව තියෙනවා Niels Bohr කියපු දේවල්. But before we write that, let's first write this note. මේ note එක ලියලා ඊට පස්සේ අපි ඒ කොටස discuss කරමු. Pura topic, planetary model. Excuse me. Planetary model of the atom. කියලා topic එක දාගෙන මෙන්න මේක අඳගන්න. You don't have to draw the diagrams very perfectly. Just include all the important parts and draw the diagram. Write these few points, and then we will discuss the rest. Make it fast. I will set a timer for 6 minutes. I hope you're writing. One more minute. Okay, time is up. Now stop writing and listen. Nah? Then මෙහෙම ඔය Niels Bohr energy levels කියද්දි there's something like this. මේ point එක ලියන්න එපා. I will just type this point because I want to explain something. Don't write it yet. Can you all hear me? Can you all hear me? මේ point එක ලියන්න එපා. Don't write, just look at the board. So මෙන්න මෙහෙම එකක් තියෙනවා. So each energy level has a specific energy. When moving away from the nucleus, energy of the energy level increases, but the difference between the energy levels decreases. So මම මේක තමයි ඔයගලන්ට දැන් explain කරන්න හදන්නේ. This is also something that Niels Bohr said. Now, let's say we have the nucleus here. මම මෙහෙම circles ලස්සනට ඇඳලා පෙන්නන්නම් rather than just drawing ugly ones. I will make it look a bit neater. So මේ තියෙන energy levels, huh? තව energy level එකක් අඳිමු මැදින්. This is another energy level. Then let's say this is another energy level. And at the middle, we have the nucleus. This is the nucleus, huh? Something like this. Right, so if you take these energy levels, now let me label this. This is the nucleus. These are the energy levels. These are the energy levels. No. Atoms have more than 4 shells. Then අපි ගොඩක් examples වලදී it's difficult to draw several circles. And we just usually in our syllabus, we only talk about 4 energy levels or 4 shells. But in A levels, if you decide to do maths or bio, you will be doing the chemistry. There you will learn that it's not just 4, there are more than 4. For our syllabus, just learning about this 4 is enough. But later on, for A levels, you will be learning that there are more than 4 energy levels, right? 5, 6, energy levels. Okay. So we have the nucleus at the center and we have energy levels. For this part only, we are only learning the first 4 energy levels. So number karot, we have 1, 2, 3, 4. Letters welling youth, we have K, L, M, N. Energy of the energy level increases, but difference between the energy levels decreases. මම මේක තමයි පෙන්වන්න හදන්නේ. These are not real values, huh? මේ real values නෙවෙයි, මම examples විදියට තමයි මේ දෙන්නේ. These are just hypothetical values. Just to show you what the 2 sentences mean. But they are not real energy levels, energy values. For an example, let's say first energy level has an energy of 100 joules. Example only, not real values, examples. Second energy level ke energy ka 200 joules. Third energy level, it's 250. Fourth energy level ke 280. Now, බලන්න මේ sentence එක, let's read this sentence again. When moving away from the nucleus, energy of the energy level increases. ඒක හරි නේද? මේ බලන්න. මෙයාගේ energy එක 100, 200, 250, 280. As we move away from the nucleus, energy of the energy level has increased, no? Energy එක එන්න වැඩි වෙනවා. The energy is increasing. Is that sentence clear to you, ළමයි? Is that sentence clear to you? Okay. Now let's look at the difference. Difference එක බලමු. Between now the energy of the first energy level is 100 joules. Energy of the second energy level is 200 joules. The gap between these is 100, 200 minus 100, gap එක 100 joules. Then second energy level 200, third එක 250. ඒ දෙනගේ gap එක 50 joules. Then third එක 250, fourth එක 280, එතන gap එක 30 joules. See, energy of the energy level increases, but difference between energy level decreases. See, මෙතන difference එක 100, මෙතන 50, මෙතන 30. The difference has decreased. Energy has increased, difference has decreased. These are only example values, okay? Is this clear to all of you, ළමයි? Okay, මේ sentence මේකත් ලියාගෙන මේක අඳින්න බලන්න. මෙතන example කියලා ලියන්න clearly, because these are not real values. Just to show you what the two sentences mean, I use some false values, right? So write this sentence and draw this again. Make it fast. Let me know when you're done. I'll give you like 1 more minute. Okay. Okay. And finally, one more thing Niels Bohr said. Niels Bohr මොනවද කිව්ව මුලින් ධම්ම? When you take electrons revolve around the nucleus in definite parts. We call them energy levels or shells. And we label them as 1, 2, 3, 4 or KLMN. Now we also said Niels Bohr කියලා තියෙනවා energy of the energy level increases when you're moving away from the nucleus, but the difference between the energy levels decreases. Then one more thing Niels Bohr had said is that there is මාතකම ලියන්න මේක ලොකු දෙයක් නෙවෙයි. හැම energy level එකකම maximum electrons ගානක් තියෙනවා. If you take the first energy level, okay, AK maximum 2 electrons. If you take the second energy level, which is L, it's a maximum, there can be 8 electrons. If you take the third energy level, which is M, there can be 18 electrons. If you take the fourth energy level, which is N, there can be 32 electrons. These are the maximum number of electrons each energy level can have. Make a taggal yagan.
Teacher, is that the standard value?
Yes, they are standard values. Done? Anybody who needs more time? Okay, Lama. So, we just started this lesson and we just did an introduction, right? And this is a lesson that I think we will do for another 2 or 3 days because this lesson is quite big, quite long. So, තව දවස් දෙකක් හරි 3ක් හරි වගේ මේ lesson එක අපිට කරන්න වෙනවා. And there's a lot of questions and all that. For the second lesson, there is a worksheet. That worksheet I will send you tomorrow. Right? Tomorrow, මම එවන්නම් ඒ worksheet එක. එතකොට ඒකත් කරන් එන්න. Next week we will discuss that as well. Since we have another like a new part, we will wrap up for today and we will start that new part next week. Yeah. So before we end the class, do you all have any questions or any concerns, anything? Or is everything clear? If everything is clear, give me a thumbs up.